Just a few comments on flow. Heart valve defects within the cardiovascular system can cause some pretty substantial issues. So let's just talk really quick about a few things, and let's try to put it in terms that we all understand, like Atlanta traffic. So in perfect conditions, our blood vessels are going to look like such. We have this nice vessel here. We got our valve, and our valve's open, and blood flow is going to come through just like that. And this is normal conditions. We call this laminar flow. I'm going to equate this to traffic in Atlanta. Let's say we're on 75 with its many lanes. And then you have cars over here. They come off. They slow the cars down behind them. The cars in the middle are going just fine. These cars over here, maybe a little slower because there's people merging in. But through the middle, everything is nice and smooth and quiet. Same is said with our heart valves. So if we have nice, easy traffic, you're driving at 3 o'clock in the morning on Highway 75, and you're in the middle lanes, everything is going really smooth. You get some what we call laminar flow. So the other opposite side of things is we have our valves closed. And then nothing's really happening here. Flow beyond here is uniform. Uniformly not going anywhere. So no flow equals quiet as well. But that's the equivalent of our hero unit out there. Let's just say there was a big wreck, and they've blocked off all traffic. So we'll just go, and then another car like that, and then ouch, it hurts over here. So no traffic flow. Behind here, the flow is nice and smooth. There's none of it. Up here, we're stopped because this fire truck closing down 75 has stopped the flow, just like a valve would in the heart. So our next condition is something we're pretty familiar with when we look at traffic. This one is called a stenotic valve. Stenotic. And this is when our valve is all messed up. Like that. And we have flow coming in. And the flow then goes, we get turbulence. So the flow is now, and we get a narrowed flow. It's a narrowed valve. And turbulent flow. And we get a murmur. So this is where heart murmurs are. So if we're looking at traffic on 75, to continue with this example, let's just say there's a stalled car right here. It's not moving anywhere. That's going to make all the other cars go around it this way. Then they're going to come back in. And we get this turbulence here. So all because of this stopped car, we now get a narrow valve, essentially. Things aren't happening, and we get turbulent flow. And what we get, instead of a murmur, we call that traffic. Maybe light traffic. Still works, you can still get home, but it isn't as nice as our nice, quiet, laminar flow. Lastly, we can get a condition in our vessel where we get a leaky valve. We also get a murmur here, but we get turbulent backflow. And let's just call that, our valves are like that. And we want it to be closed, but what's really happening is we're getting some fluid back this way. And what ends up happening is that when it comes back through this way, we get this turbulence. Like so. And it's a leaky valve. So in the case of traffic, I don't really have a better example for you other than if our fire truck up here was still in place, and people got fed up and they decided they wanted to go this way, back that way. Their car's this way, going in reverse. You can see how that's going to influence the other flow of the other traffic this way. So someone going down the wrong way on a one-way street would pretty much do the trick on that. So let's just draw a one-way street. One way. It's supposed to be this way. So it works great most of the time. All our cars are going this way. But then we have some guy that wants to go this way. Maybe one more. And as they approach the other cars, we can see that it's going to cause some disruption. They're going to have to get out of the way, the other cars are, and we get this turbulent backflow, some leaky murmur.